All right, and welcome back. In this video, we are going to be going through something that is called function notation. And it's what's going to look like when we have something that looks like that. We call it f of x. You might see g of x. You might see h of x. But this is what we call function notation. Is going to be our topic today. So please have out your guided notes to follow along. And let's begin. So you can use function notation to write a function. So if you look at the first function, we can read it f of x is equal to 2x minus 3. We sometimes would see an equation look like y is equal to 2x minus 3 as well, which is synonymous. But when it comes to function notation, we are specifically going to read it as f of x equals 2x minus 3. And what we can do is we can evaluate our function for individual values. So for example, in this first prompt, it's asking us to evaluate the function at 0, the function at 1/2, and the function at -2 for the overall function 2x squared minus x plus 1. So what we're going to do is we're going to substitute 0 in for x in the function, and we're going to evaluate. So everywhere in this function you see an x, you're going to replace it with 0. And you'll notice that within f of x, we now have f of 0. We're not doing f times 0. We're saying the function at the value of 0 is then what with it. And when we continue this over into the other two values, we have f of x is equal to 2x squared minus x plus 1. And again, we're going to evaluate the function for 1/2. So we're going to replace it as f of 1/2 is equal to 2 times 1/2 squared minus 1/2 plus 1. And then we would figure out our value from there. And again, we're not doing f times 1/2. We're saying the function evaluated at 1/2 would end up as 0. So we would say, hey, f of 1/2 is equal to 1. We could do the same thing by substituting x as -2. So again, anywhere we see an x within our function, we're going to replace it with a -2. And we would evaluate our function at the value of -2. So we would say, hey, our function evaluated at -2 ends up to being 11. And this would be our final answer. F of -2 is equal to 11. And with that in mind, please work on problems 1, 2, and 3 on your guided notes and resume when you're ready to move forward. So we can also plot ordered pairs on a coordinate plane to graph a function. We sometimes are able to graph a linear function, sometimes it's not going to be a linear function. But we just want to have different coordinate points on a plane. So you would see that we have what we call a mapping diagram. This is called a mapping diagram, where you have your x values and your, and your f of x values. We also call it your input and then your output. So what this is telling us is that, hey, 3 as our input turns into 2 as our output. And you'll see that there's a point, 3, 2, plotted on our coordinate plane. Likewise, 4 is our input and 5 is our output. So 4, 5 would be plotted on our coordinate plane. Likewise, 5 goes to 9. So that would be plotted on our coordinate plane. And 6 goes to 14. So that would be plotted on our coordinate plane. But these values are not going to be connected because we don't know what they are. We don't know what 1, 2, 3.5, 4 3/4, 5 1/3. We don't know what those values are. So we're just going to plot the ordered pairs on the actual coordinate plane. And we also, if we had a function itself written as f of x is equal to -2x plus 3, what we can do is we can make a table. We can plug in an x value evaluate it, and then receive the output of it and plot it. So for example, if we had the x value of -2, we would input that into our function, evaluate it, and we end up with 7. So -2, comma 7 is plotted. Well, we can do that process again, and we can choose our own x values. Sometimes they're going to be given to us. Like in here, -1 is given to us. And then we're going to input it into our function, evaluate it, so that value becomes 5. So -1 goes to 5. And you'll see that there's a pattern happening here. Well, 0 is our x. We plug it in, and we end up with 3. So therefore, we can plot 0, comma 3. We can continue the process. Where 1, when we input into our function, we evaluate it, and we get out the y value of 1, so we can plot that. And lastly, if we had 2, well, 2, we can evaluate that into our function. We get out the value of -1, so we would plot 2, comma -1. Now, these points are going to be defined. We can connect these because we're given the overall function. We're not giving a mapping diagram, isolating a couple of values. We are given an overall function, so we can now start to connect the dots and connect the points together. With that in mind, please work on problems 4 and 5 on the guided notes. Please let me know if you have any questions when you are going through. You're doing a great job with this. Keep up the great work. Let me know if you have any questions, and I'll be talking to you soon.